everyone, welcome to our channel Euclid Mathematics. We have started lecture series on integral equation that includes previous year questions from CSIR, SET, GATE and other multiple competitive exams. Plus, I'm going to cover here few topics which is more important for this such a exam. Videos on these topics. Okay, so if you wanted to check my videos, you can check it through my playlist. Okay, I added more videos there. Okay, so in my today's video, I will explain some more example from CSIR, okay, SET and GATE exam also. Okay, to find out the resolvent kernel. We have started resolvent kernel in my previous lecture. I completed 2 to 3 lectures on resolvent kernel. So if you wanted to check these videos, you can check it into my playlist. I added these videos there. Okay. Now here you can see we have examples from June 2015. Okay, which are for the 3 marks. And from now onward, I will explain these examples in a short trick. For full answer of this question, you can check it into my playlist. I added the method for finding resolvent kernel. You can find that way very easily. But now we wanted to learn the short trick to find out the resolvent kernel. Okay. So here I'm here with the question. The resolvent kernel R of xt lambda for the Volterra integral equation is given. Okay. So we want the resolvent kernel as R of xt lambda. Okay. And Volterra integral equation is given. So let's find out its solution. Okay, by using short trick we will get the answer. Okay, so k of xt we can see it is here as 1, coefficient it is given 1, lambda it remains same because lambda do not have any value, lambda is having value lambda itself. Okay, so first of all check out our first property that k of xz into k of z is equal to k of xt, it is hold or not. Okay, so if it is constant, surely this will come 1, this will come 1 and this will come 1. Okay, so k of xt is 1. So k of zt, k of zt also 1 and k of xz also 1. Okay, now substitute these values here, we get the 1. Okay, so 1 which is equal to 1. So right hand side and left hand side are both equal. Okay, if both sides are equal, then use only the one result here. Okay, so resolvent kernel of R of xt lambda which is equal to k of xt e raised to lambda into x minus t. Okay, so k of xt is 1 and e raised to lambda into x minus t, it remains same. Okay, because lambda we do not have value, x minus t remains same. Okay, so we can see here the option number B which is correct. Okay, so R of xt lambda is equal to e raised to lambda into x minus t. How easy that answer is. We can answer that such a question just observations only. Okay, that you need to remember this property first. If that property hold, then move for this one. Okay, and in 99% cases such properties are hold. Okay, I hope so you all have understood this example. Okay, let's solve one more example similar like this. Okay, so I'm having here a next example which asked in June 2018. Okay, June 2018, example number 12 is there for 3 marks. It's very easy question, just we can answer it orally only. Okay, but let's solve through our trick. Okay, so we can see here our question, the resolvent kernel is given for integral equation. Okay, so phi of x is equal to x square plus 0 to x e raised to t minus x phi of dt. Okay, so this is the integral equation. Then we want it's a resolvent kernel. Okay, R of xt lambda. Okay, so k of xt, what it is the value, k of xt e raised to t minus x. Okay, this one is the kernel of our integral equation. Lambda which is here 1 because lambda not given, that means lambda has a coefficient 1 and that is the value for lambda. Okay, so I got the k of xt is e raised to t minus x and lambda is a 1. Okay, so now let's find out the first property for our resolvent kernel. Okay, k of xt which is equal to k of xz into k of zt. Okay, that property has to be hold. Okay, if it get hold, then we can say that resolvent kernel result we can applicable here. Okay, we can apply here. So I hope so this one is easy. Okay, to find out whether that property hold or not. Okay, so you can find it by your own. So if you found any difficulty, comment me in comment section, or you can watch my previous lectures. Okay, I added their same types. So similar like above example, you can check it first property. Now first property hold here. Okay, now let's move for the second, R of xt lambda which is equal to k of xt into e raised to lambda into x minus t. Okay, and just verify these two sides, it come or not. Okay, so R of xt lambda which is equal to k of xt, what is the value for k of xt, e raised to t minus x. Okay, it remains same, and lambda it is here 1, put it here, e raised to 1 into x minus t. Okay, e raised to t minus x into e raised to x minus t, base are same, so add their powers, t minus x plus x minus t. Okay, minus x plus x cancel, plus t minus t cancel, so it remains 0 only, so e raised to 0 is a 1. Okay, that means our required resolvent kernel for our integral equation is a 1. Okay, so it's quite easy by using that short trick. So you can find out that answer just an observations. Okay, so if you want that answer by using the method of a resolvent kernel, so you have to find out first of all iterated kernel. Okay, as I found in my previous videos. Okay, so if you wanted to check how one can find that video, iterated kernel and then resolvent kernel, you can check it into my video. Okay, so I hope so you all have understood my this lecture. For similar lectures, you can check it into my playlist. If you want any other video like these videos, you can comment me in comment box. I will upload more videos as per your difficulties and doubts. Okay, so thank you everyone. Thank you for my today's lecture.